Hi, welcome to SAP BW class. For this class, I will explain you for 5 topics. The first one, overall. Second, BW HANA data management. Third, optimization areas in BW on HANA. Fourth, modeling with SAP's reference architecture LSA++. And the last one, data provisioning. Okay, let's go for the first topic. Let's talk about database technology. For SAP BW traditional, database systems were decided to perform well on systems with limited RAM. Its low disk I/O was the main bottleneck in data throughput. Architecture was decided to focus on optimizing disk access. So it means mainly is on disk access. But for the new technology, SAP BW on HANA is the modern server can have more than 2 TB now, allowing complete database to be held in RAM. Multi-core server architecture allows CPU to process included data per time interval. Cost-effective so as to replace disk-based data storage by in-memory solution. So it means it replaces the disk-based with the in-memory solution. Okay, for the leverage existing technology and SAP BI evolution. Previously, we used BW accelerator, BWA. Data is loaded from BW to BWA for in-memory accelerator. If indexed in BWA, queries see large performance improvement, and BW architecture remain unchanged. The process BW server and go for BW appearance. But for the new one, we have BW on HANA. Data exists directly in memory. All queries see large performance improvement. The loading also large improvement. BW architecture is simply. Enterprise edition include HANA Analytic Foundation with HANA Studio for next generation analytics. You see the HANA database. HANA Studio Modeler. We have SAP HANA, which is have HANA Studio Modeler to create a model like you could develop the sales model, inventory models, and any application business that you would like to design, or even it has a HANA content in itself. It's allocated in HANA table, virtual table, and it can integrate from Teledata, Hadoop, SAP HANA, ASE, and SAP IQ as well. It's for transaction path analytic. And you see for BW modular. BW modular, we have the layer of SLA, layer scale architecture ++. Data acquisition layer. This one is for the database modeling. Data modeling like Open ODS view, Advanced DSO, go for EDW transformation, EDW propagation layer for reporting, and business transformation, architecture data mart, and this also for BW virtual data mart layer, which is can create Open DSO view from HANA table, HANA view as well. Or even we can have the data from SAP IQ, and which is a flexible data mart BW workspace. This can be the modeling on BW itself, and we create BigQuery on top and up to business object for web dashboard analytics and any application for business object. Okay, SAP BW, SAP NetWeaver BW on SAP HANA. How it works? SAP NetWeaver BW operates in SAP HANA as its database. BW does not exist directly on SAP HANA. It sits on a server in a multi-cloud landscape. BW appears very simply, and it did per SAP HANA except new performance are available, such as composite provider, transstance provider, to be able to consume data that was loaded directly into HANA appliance. DSO are now column stored by default. Info queues are not really needed except in unique cases such as non-cumulative key figures, for example. A HANA optimized queue denormalize the queue, so dimension table are integrated into fact table, so it's no dimension anymore for HANA optimized info queue. Why SAP HANA? SAP HANA is an in-memory application platform that could perform more than 1,000 faster than traditional database. SAP HANA contains application, database, and integration services. The main concept of SAP HANA is column store and row and column store, partitioning and parallelization, completion, insert only on delta. See the first one, the first concept. If you see this table, it's mapping to memory like this. Is if in all row it will be $10 and $B, so it's in on row base. Okay, but if in column, if you come like this, A, B, C, D, 10, 35, 2, 40, 12, and $, C is much faster for the data stored in column, enable faster in memory processing of operations such as aggregate. Columnar layout supports sequential memory access. A simple aggregate can be processed in one linear scan massive. Parallel processing possible per column as well. And the second concept, partitioning and parallelization. The initial data separate in each table, and you see is run parallel for each table. The spread table contains cross brackets. Work on smaller set of data in parallel. And the third, completion column store table. You see the table, the information, the raw data, and the dictionary go up. If we want to find like Denmark is row number 5 here, and it contains 2 Denmark. So it's really 5, 2. It's go for faster for Denmark. This means dictionary per column. Use data-driven fixed length bit encoding. Operation directly on completed data. Using integer, more in cache, less main memory access. And the last concept, insert only on delta. The storage separate for column store table in memory, main and delta. Enable high completion and high write performance at the same time. See? Main. So it's complete and least optimized for the main table. So this one is in column store, and is enabled for lead operation only for the main. And once the new data comes, is like operation. The data come right operation and go for lead. So first delta come column store, not store. It means the delta number one is column store, but it's not store. The second row store. Delta merge, what it means is transfer record of delta store to main store. So if we have the delta merge, it means the delta store it will move to main store and reorganize main store. For the write operation, it's only on delta store. The update is performed by inserting. For the read operation, for both main and delta storage. This means for the delta table, it will have like a read and write. But for the main, it's only for read. What is delta merge? It will move the data to main table. So the delta will delta store to main store and reorganize main store as well. That's the concept.